Good morning, Calc 3 class. Hope you guys are doing well. I just had a lovely breakfast with decaf coffee and eggs and a gazillion morel mushrooms. We actually found more than we can eat, almost. We ate them all, but we're about done with morels, although I'll probably keep looking because they're so much fun to find. Anyway, today we're going to dive into section 12.6, and I think you'll find it's much shorter than 12.5. 12.5 always takes a while to work through. But hopefully, if you'll put the time in on 12.5, then 12.6 shouldn't be too bad. So I'm going to show you a new coordinate system in 3 space. So far you know the Cartesian coordinate system and then polar coordinates in 2 space. But I want to show you a new coordinate system called cylindrical coordinates, which is basically just polar plus the z. It's polar in the xy plane plus the z coordinate. So let me show you how it works. So let's pick a point right here in 3 space, and we're going to drop it down and assume that it's right there as its projection in the xy plane. I just want to make sure that we can all see that. Okay, so this is my point in polar, and I'm going to think of it as some r comma theta comma z, and the z is exactly what you think it should be. It's the same z as before. This is just z. And then the other part is just regular old polar. So here's x, this is the y-axis, this is the z-axis. And so my angle theta is the same as before. And then my r, this length right here, is going to be my r. So that's cylindrical coordinates in a nutshell. So take a moment and ask yourself, what's the coordinate for this point right here, the one below P? Well, this would be r theta, and then z would be 0. So you can just adjust the z values by going up and down like that. Okay, so I'll just say a couple of words. The usual conversions between x and y and r and theta still hold. The big takeaway is that we're not going to switch z. Z stays the same. You don't convert z to anything. So it's still just x equals r cosine theta, y equals r sine theta, and then by the way, z is just z. R squared is, as before, going to be x squared plus y squared. Tangent theta, just like in polar, is y over x, so on and so forth. So I won't really belabor this too much because we've been working with polar. Let's scroll down though and do an example. Let's convert this point in the cylindrical coordinate system. Let's convert it to a point in the Cartesian coordinate system. And so we're just going to realize that, well, x is r cosine theta, so x is 2 cosine of 2 pi thirds, which is what, 2 times minus a half, which is -1. Y is 2 sine, or r sine theta, so 2 sine 2 pi thirds, which is 2 root 3 halves, which is just root 3. And then, of course, z is just z, so z is 1. And so the point in regular Cartesian coordinates would be -1 root 3, 1. That's how you can go from cylindrical to Cartesian. And then the other way is, in some ways, easier. So I'll stop this video here, and we'll pick it up with the next one.